This is Pre-Calculus 2.3 Day 2 notes, and today we're going to talk about the remainder theorem and the factor theorem. And the remainder, when you divide by x minus k, the remainder is f of k. What does that mean? If you had x minus 3 and you divided some polynomial by x minus 3, then I have 3 for the synthetic division, and I get a remainder here. Say the remainder is 7. That means that if I put 3 into the polynomial, the height of the function at 3 is 7. The remainder is the height of the function at that x value. So if you divide by x minus k, and if you put k into the function, you get the remainder. So P of 3 would be 7. All right, and then the factor theorem says that this is a factor if and only if f of k is 0, meaning that if this ends up being 0 as the remainder, or 0, then P of 3 is 0, meaning at 3 the height of the function is 0, meaning at 3 it's on the x-axis. 3 is an x-intercept. And if 3 is an x-intercept, then x minus 3 is a factor. So those are some pretty powerful things, the remainder theorem and the factor theorem. And so you're going to be factoring polynomials of degrees 3 and higher in your assignment. And they start by giving you a solution here to this. And so that means when you put 6 into that polynomial, you're getting a value of 0, because when you put negative 6 in there, it satisfies it. It is a solution, which means that a factor is x plus 6. And what we're going to do is we're going to do synthetic division, and you use that x value of negative 6 in the synthetic division. You have a 1x cubed, you must have a 0 for the x squared. You have a negative 52 and a negative 96. And then bring down the 1 and multiply. And you get the negative 6. Add. Then you take the negative 6 times the negative 6, and you get 36. And when you take a negative 6 times a negative 16, you get a positive 96, and you get a remainder of 0, which needs to be if negative 6 is a solution to what makes that 0. And what that tells us about factoring is this x cubed minus 52x minus 96. If I divide it by x plus 6, then these are the coefficients of a polynomial 1 degree less. This is cubed. This is a 1x squared minus 6x minus 16. And that's what's left when you divide by the x plus 6. So these are the coefficients of your quadratic. When you divide by x plus 6, this is what's left over. And now it is quadratic, and so you have skills to factor. Numbers that multiply to be negative 16 but add up to negative 6. You have a x minus 8 and an x plus 2. And so you were asked to factor completely. And now that is factored completely. In your homework, they ask you to show that x is a solution. And use the result to factor. And when we say factor, it always is factor completely. And then it wants you to list all real zeros. So in your homework, you are showing that -6 is a solution when that remainder comes out to 0. Because this means that f of -6 is 0, or the polynomial at -6 is 0. So this shows that -6 is a solution. Use that result to factor, so when we divide, we're using that result, and you can factor that. And then the real zeros are the -6, the +8, and the -2. So that factor theorem is very helpful here. Then you're going to get a polynomial even of a higher degree, and they give you 2 factors. And when those are factors, this means f of 3 is 0 and f of a -2 is 0. That's the factor theorem. And so what we're going to do is just use one at a time to help factor completely. And so we'll work with 3, and then we have a 1, 2, -7, -20, -12. And do the synthetic division. Bring down the 1, multiply, add, multiply, add, multiply, add. And it has to come out to 0, or you know you've made an error, because they tell you these are factors, so the remainder must be 0. And I want to see, what does that mean in terms of factoring? F of x is x minus 3 times, these are the coefficients of a polynomial of 1 less degree. This is 1x cubed, 5x squared, 8x plus 4. That's the result when you divide by x minus 3. You get a 1x cubed plus 5x squared plus 8x plus 4. So I want to see what this means in terms of how does f of x factor, and make sure that you have it equal to f of x. However, we also have x plus 2. If I divide this by x plus 2, I'm just going to get a different cubic. If this is divisible by x plus 2, and I haven't divided it by x plus 2 yet, this must also be divisible by x plus 2. So we are going to now divide this by x plus 2. Now you already have all of those coefficients right here, so you can just use the -2 and continue synthetic division right here. Or if you're not comfortable with it, you can, rewrite it, but remember you're using the result after dividing by the x minus 3. Because you need to keep whittling it down to something you can work with. And so bring down the 1, multiply, add, multiply, add, multiply, and it better come out to 0. Because you were told they are factors. And so what does that mean for factoring? that cubic factors into x plus 2 times, these are your coefficients of a polynomial of one less degree. So these are your coefficients for x squared, x, and your constant. And so you get a 1x squared plus 3x plus 2. Those are the 1, 3, and 2. 1, 3, 2. And now that you've got it down to quadratic, you have other skills to factor. Numbers that multiply to be 2 add up to 3 are 2 and 1. And then we have a repeated factor. We have a repeated factor. So we get f of x is x plus 2 squared. And that is factored completely. Now, you're going to have additional directions when you get these in your homework. They want it factored completely, but then they want you to list all real zeros. I think that's part D. And part E, they want you to confirm with a graphing utility. So you would continue on, set it equal to 0. That's how you communicate you're finding zeros. And your zeros would be negative 2, 3, excuse me, and negative 1. And for confirming with a graphing utility, you can just put that into Desmos. And when you have a multiplicity of 2, an even degree, you should expect that there is a bounce in the graph. It touches there and goes back in the same direction. When you have these to the first, it's odd, and so it passes through at those values. So let's see what happens. I have it up there, x to the fourth plus 2x cubed, that's there. And notice at negative 2, that is a 0, and it bounces. It comes down and goes back up. And then at negative 1, it passes through. And at 3, it passes through. So those are the zeros. And another key point is the y-intercept. I want that graphed because the y-intercept is the constant. And that constant's a negative 12. And notice it passes through at negative 12. So that's a key aspect that's easy to find, and that should be included in your graph. So anyway, so it checks with what we saw in the factored form. Now, you're also going to have a worksheet. And in the worksheet, they want you to do the sign test. And using the sign test and what you know about end behavior, they want you to sketch a graph. So for the worksheet, after you get it factored, we should have a number line. And that when there's 3 zeros, there are 4 intervals. And you have negative infinity to negative 2, negative 2 to negative 1, negative 1 to 3, and 3 to infinity. There are 4 stretches there, so you need 4 intervals. And then you need your test number, and I want your columns labeled like this. And you need a value to the left of negative 2. You need a value between negative 1 and negative 2, negative 1.5. You need a value between negative 1 and 3. If 0 is in the interval, then I'm going to use 0. And to the right of 3, I'm going to use 4. And then you need to write your factorization because the order of your factorization is not necessarily the same as mine. And the last column is the overall sign of f of x. So you put your test number into here and to just determine if it's positive or negative. Well, this quantity is squared, so it is going to be positive for every value. A minus 3 is negative. A minus 3 plus 1 is negative. Negative times negative times positive is positive. A negative 1.5, because that quantity is squared, no matter what it is, it's going to be positive. The next ends up negative, and the last one ends up negative. And so it remains positive, which should make sense because we said at -2 there is a bounce because it's of even degree, so there isn't a sign change. The function doesn't change from being above to below. It stays above on either side. And then for 0, it'll be positive, negative, and positive, meaning overall you're going to get a negative. And for 4, they are all positive. And so you go positive. So at -1, it changes sign, and at 3, it changes sign, which you expect because they're of odd degree. So then for sketching a graph, the y-intercept of this is -12. So without a graphing utility, you need to have the graph pass through on the y-axis at -12. You don't have to put a scale other than at -12, wherever you graph it and it crosses the y-axis, make it -12. And that's it. That's all you have to show for a scale on the y-axis. And so we have a -1 and a -2, and over here we have a 3. And it's positive on the left and on the right of -2, so comes down, touches at -2, goes back up, and then it's going to end up crossing through at -1. It goes through at -12, and it needs to come back up and go through at 3. And that's perfectly fine. It needs to go through each of the x-intercepts correctly. You need to show that it crosses the y-axis at its y-intercept of -12. And further, it's touched down. It's both ends up. It's x to the 4th. The degree of this is 4, and it's a positive leading coefficient, so both ends should be going to positive infinity. So that's another check. All right, so today you have this 2.3 day 2 assignment, and you have a worksheet. Actually, I think it's just kind of a nice assignment.